Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and today in the news we have some interesting articles. So, the first article that I already mentioned in lecture 2, there I was reporting on the 1 billion row challenge. As an argument that machines today are fast and vertical scaling is mostly good enough. And the solution I was looking at was written in Java, but I now searched a bit and there are solutions for this 1 billion row challenge in other languages as well. It's the following challenge here that I presented the last time about what kind of optimization went into this um, program. And in the meantime, I found some different languages that also try to solve this 1 billion row challenge. This, for example, is in Go, and he managed to bring it down to 4 seconds, but he didn't use any kind of unsafe methods. So, still within, I would say, in a maintainable state. Another author went a bit further, not this one, but for example, this one here. It's also a solution in Golang, and here we already see how the code looks like. Lots of magic happening here. There are also unsafe methods, like, for example, down here on save add. So this makes things faster, but you need to know what you're doing. And this makes also the code not as maintainable as it should be. There are other languages, for example, in C. And here he managed to have it in 1.6 seconds. And if you look at the source code, he has it in 7 iterations. So let's take the last iteration, and here we see it doesn't look that bad. It looks actually quite nice. And also the Rust version he measured here 1.64 seconds. So if we take a look here, this is the library part where he processes data, parses the temperature, and here he has the main entry point. And this looks also quite reasonable, also quite fast. And there are more solutions, for example, one in Node. And here he managed to bring it down to 23 seconds. And there is even a Bun version, or the same version that was tried to run in Bun. It didn't run actually, so it only read until 65K, so the size of the buffer, and then it didn't continue. So it didn't run, but so the small part that was processed on one core suggests that it might be faster, but we don't know because it crashed. So, very interesting challenge from a language perspective. Of course, these numbers cannot be compared, but it's at least interesting to see the magnitude because the testing was done on different machines, different setups. Some tricks were possible in one language, some were not possible in other languages. So the comparison is not really fair, but it shows that if you look at the code, if you look, for example, at the C code and the Rust code, those are low-level languages and they're pretty fast. And you could become also fast with Java, Golang, and probably other languages as well, but you would need to use mechanisms, bit shifting, or unsafe methods. So go out of the comfort zone of that language and implement it in a hacky, I would say, unmaintainable way. But then you get the speed. But for production quality code, I would not recommend to do that. So here we see a clear trend. See Rust, they're pretty fast. Code looks clean. You can get fast with Java, with Go, probably with others as well, like C Sharp, but the code is not maintainable anymore. And if you look at Node, The code looks maintainable, it looks good, but it's rather slow. And again, comparison is difficult, so just look at the magnitudes, because if it's on a different machine, it can have completely different behavior. One has 20 cores, the other has 10 cores, but it's just about the order of magnitude that's interesting here. And again, so for production ready code, don't optimize until it's really necessary. So if you do this calculation once, it's perfectly fine to run it in 2 minutes if you just need it once. If you need to have this constantly, you need to calculate it constantly, then you need to start to optimize. Then in lecture 3, I reported about broken C cables. It's the following slide here where I said, or where I mentioned that C cables might be broken, but I also reported that Cloudflare Radar did not report outages. And it turns out actually there are broken C cables. So there are now reports out there, for example, here. The following article, it's in German, unfortunately, but here they confirm that 3 C cables are broken. There are other articles mentioning there are 4 C cables broken. And these articles mention that the damages were due to a ship's anchor, and the ship was attacked by Houthi rebels. And due to that, this anchor damaged those 3 or 4 C cables. The internet was rerouted, so probably that's why Cloudflare Radar didn't pick it up. And also the next article, it's about Facebook, and they also had recently an issue. There was a massive outage at Facebook. That means if your services relied on Facebook login, for example, your services were not accessible. So even if your architecture is highly distributed, such as Metas, for example, services still can fail. And keep in mind that if you have a distributed system, this system can be quite complex. It has many moving parts that need to work correctly. And this also happens in systems that are built for high availability. In lecture 3, we looked into web push notifications in the admin part, and I mentioned the following article here. This article is about the European Commission that is looking into Apple's decision to stop supporting web apps on iPhones with iOS 17.4 only in the EU, and making these apps more functioning like bookmarks rather than standalone apps. That would also mean no integration for web push notifications. This is a response from Apple that they now need to include third-party browser engines, also on pressure from the European Commission. This is the EU Digital Market Act, and they argue that they need, for security reasons, they need to disable these kind of web features. But this has been met with criticism from developers and advocacy groups. And now they responded, and the update is here. Here it says developers and users who may have been impacted by the removal of home screen web apps in the beta release of iOS in the EU can expect the return of the existing functionality for home screen web apps with the availability of iOS 17.4 in early March. So that's good news. The next article is a blog post. It details a personal project deploying fiber optics. I think this is very interesting. It's the following article here. It explains the decision-making process behind selecting fiber cables, the consideration for cable types and protection, and the process of fiber splicing and testing for connectivity. And the author also shares insights on designing scalable and modular network infrastructure within the home, highlighting the project's challenges, successes, and technical capabilities achieved through the installation. It's a very nice article. So if you plan to make your home ready for the future, if you want to have the network with fiber connectivity, so this article is for you. What I also saw from this author, if we go here, I saw this author, sorry, that one here, that this author even has its own autonomous system. So that makes me a bit jealous, but this is really cool to have it. I quickly looked up on how difficult it is to get such an autonomous system. Here is a report on how to do this, but this seems quite a lot of effort. So I'm not ready to do this yet, but I think this is really cool to do this. The next article is also about home labs. This article serves as a comprehensive guide for beginners interested in setting up a home lab, detailing all the essential hardware recommendations and some setup tips. And it emphasizes the importance of selecting the right location within the home for the lab, considering factors like room temperature or noise level. And moreover, it provides insight into choosing between network cabinets and racks based on specific equipments, about the dimension of the equipments. And also the author updates the article with his personal choice and experience. So this is down here. Here he has some upgrades. He details the upgrades. He has UPS, uninterrupted power supply installed. He has cooling solutions. So this is a really interesting article. And yeah, the last update was a couple of days ago on 8th of the March. So very interesting. The last two articles, they are projects, not really articles, but I stumbled upon them. This is Docker U. Docker U, it says Windows in a Docker container. It's actually not Windows running in a Docker container. It runs in a virtual machine. For that, it uses KVM. But the great part about this is that the installation is fully automated. And with this command here, docker run, you have your Windows installations ready in 2 to 3 minutes, and you have Windows 11 running. You still need your activation keys because this is not provided, but the installation is non-interactive. So installation within this Docker environment, all the dependencies in this Docker environment, but in the end, it runs in a virtual machine, and I installed it. I can log into my machine here. So this is the project here. I can run, so I did run this command, then I installed it, and here I have my Windows machine where I can now open a browser. This is Edge, and go to my website. The second interesting project I stumbled upon is Docker C. This second project is a way to run your containers without installing Dockers. This defeats a bit the purpose of Docker, where you know that it runs in an isolated environment. But here they ship the required binaries and libraries. For example, crun. We see this here in tools. So this is necessary to run Docker images or container images. And it's an interesting concept. for your own Docker images, because if you know it's your own Docker image, you have now a binary, you execute this binary, it's fine, but I would not use this for third-party images. For third-party images, when you run these containers, I still would rely on the isolation of Docker so that it runs within Dockers, so that you won't execute any kind of binary that you downloaded from the internet. Rather, you will execute it in a sandboxed environment. But nevertheless, I think it's interesting for smaller projects, for personal projects where you have the control over the whole supply chain. So you create your images, you run your images, then it's an interesting concept. But for production use, I would not recommend this. In this week, we saw some articles about home labs. I also have some equipment at home. It doesn't look that polished and it's still not finished. For example, here we see the fiber cable still not spliced, still not set up. The cables are there. I just need a bit time, and hopefully after I have successfully patched all up, spliced all the cables, I can also publish an article on that.